Thank you. I always like repeating myself after I forget to record too. It's always so awkward. It's like, so the t-test, as I told several of your groups out in the breakout rooms, this is essentially very similar in terms of purpose as the non-parametric tests that we've already covered, the Mann-Whitney U and the Wilcoxon signed rank test. So there are really two types of t-tests I want you to learn about this week. The first one is the t-test for independent samples. And what we mean by that is that it comes from two different groups. We are comparing average scores for two different groups, okay? So oftentimes in my work, we are always looking at male access to education because men are not going to higher education at nearly the same rates that females are. So this is a very common two-group scenario that we look at and we compare average high school GPAs, average ACTs, all these other things. A paired samples t-test, however, is looking at two different averages, two different group averages that come from the same population or the same sample. So I was telling Juliana in our breakout, I said, one example of this within maternal health, right, which is her interest, would be for paired samples, measuring, and this is just simple because with my wife and I have a conversation about this every once in a while. She's like, if I ever got pregnant, I'd probably never be able to lose that weight, right? And so she said that, what the average weight is for women pre and post birth. So pre-pregnancy, post-pregnancy, 6 months out either way. That's one way of looking at paired samples, right? You're looking at average scores or average values for the same group of people at 2 points in time. For the independent samples, again, these are very different groups. There's absolutely no overlap at all, right? Students in one group can't be in the other group, okay? So, Mann-Whitney U is very similar to the independent samples t-test. Wilcoxon signed rank is very similar to the paired samples t-test. The reason we did non-parametric tests first was to help you remember all of those assumptions that come with these types of tests, right? Now that you've understood the assumptions of normality, homoscedasticity, all that stuff, independence, observations, now we can get into what happens when we meet those things. There we go. All right. So in SPSS or Excel, I'm actually going to work through the t-tests in both tonight. We're going to do the t-test in both. The t-test is a fairly easy, pretty straightforward test, but it's super useful. 9 times out of 10, we're comparing groups, right? And if we're only comparing 2 groups, then the t-test is the most efficient way of doing that. So first thing we want to do is, of course, explore our data, check for any outliers, all those sorts of things, and then run the t-test. And there are ways of bootstrapping. If we do have problems, we're going to assume that we don't have problems for the purpose of simplicity tonight. And then, of course, we run our t-test, we get our p-values, and we determine if we have a statistically significant difference in the average scores or average values, whatever they may be. So I should have changed this, but I like this example a lot. Go Braves, right? I should have maybe made it some baseball data. But the NBA has a lot more rich player data than other sports do. Hockey data is pretty good, but no offense to anybody that loves hockey. My neighbor 2 doors down, the only person I know that loves hockey. So I thought it would be easier for us to kind of talk about basketball data. Does anybody here love basketball, by the way? Kara loves basketball. Okay.
Yeah,
Anybody
I
else?
do.
Roxanne? Okay, cool. Anybody else fairly knowledgeable about basketball? A little bit? Okay.
I note, I would not call myself knowledgeable. I just very much enjoy it.
Okay, maybe I should have clarified it. Yeah. Okay, so I'm 5'10", but my best friend, the guy who introduced me to D, he is 6'4", and when he and I play basketball, I am like all about defense with him. So I like it, but what I really like about basketball is it is a small team sport. If you think about it, how many other sports out there have more than two people on a team? And I'm thinking like mixed doubles tennis, right? That's just two people. Or cornhole, right? Two people generally, I think. I don't know. I'm not that well versed in cornhole. But if you think about baseball and you think about football and you think about soccer or hockey, there's way more than just 10 or 12 people, right? The NBA, I mean, it is a very small in terms of number of players type of sport, especially at the college level. And even in the NBA, there's some depth, but not nearly a football team, right? Football teams have more than 150 players generally. It's insane. So the reason I'm saying that is because I think it's very interesting to see if there's differences between groups and sports. And we can create our own groups even though they may not naturally exist. And what I'm thinking about are, hey, when were you drafted? Were you drafted first overall versus second overall? And is there a difference between your salaries or your free throw shooting, right? Everybody remembers Shaq, Shaquille O'Neal, the Shaq attack? He was terrible at the free throw line. But he's still a very hot, I think he may have been drafted first overall or something like that. Anyway, lots of data here. I've got the data. There's the website, basketballreference.com. If you want to go out and look at it yourself, we've got date of birth, where they were born, what college they played for, what draft pick they were, what round they were drafted in, who drafted them, when they got drafted, their height, their actual high school name. Just because they may have grown up in Little Rock, we've got 6 high schools, right? Some high schools are well known for producing these star players. The player name, what position, if they shoot right or left-handed or both. I mean, come on, that matters. I don't know if it does. Their weight, how many seasons, what their maximum salary was when they played for the NBA. And then I did a little extra credit for y'all. I went and I calculated an adjustment. So if you've never adjusted for inflation, I'm sure you've probably heard that term, right? Adjusting for inflation. What that means is that the dollars that I got paid back in 2008 when I started my career would actually be more money now, right? In terms of like numerical value. Just because everything else has gone up. And so I've adjusted all of these players' maximum salaries going back to 1985 for inflation for you. So the most recent data I have is from 2018. So that's of course a 1, right? That's in 2018 dollars. So what that means is, here, let's look, give me a player name. Who's y'all's favorite player?
Do LeBron.
Say that again.
I said do LeBron James.
Oh, LeBron. There you go. Let me go for it. Let me find him. Maybe. Yeah, there he is. All right. So I'm just got LeBron. There he is, right? So look at that. He's in here. He was picked in the first round, first overall, right? Back in, he was born in 84. He's a year younger than me. And what's his maximum salary? his maximum salary was $33 million a year. Okay? That was actually in the last year of data that we collected for this, 2018, right? So $33 million adjusted for inflation in 2018, from 2018 is $33 million, right? Right? You see that? Okay. But someone who made $30 million in 2013-14, in today's money, that would have been equal to $32 million. Does that make sense? How to read that? Okay, cool. So, Bratane, LeBron James, first overall, first round. Anybody else have a favorite player they want to look up?
Oh, Brian Grant.
Spell it for me.
BRIAN GRANT. No, I.
Oh, I.
Yeah.
There he is. Man, Sacramento Kings. Look at this. We're going West Coast.
Yeah.
Let's see where he's small forward. Weighs about 100 pounds more than me. He's not very small. Always laugh at the position names. But yeah, so there he goes. He's born in 72, about 10 years older than LeBron. He was 8th overall, but also came in the first round, right? His salary back in 06-07 was $14 million, which is actually almost $18 million in today's dollars. Okay, cool. So now everybody feels pretty comfortable with the data? You see how it works? Have you downloaded it yet? Download it.
I was just too enthralled watching you. I have, you said it's under week 10?
Give me a sec. It is.
Yes, Laura Beth, that's where it is.
Thank you. Yeah. Week 10. NBA basketball players example in Excel. All right. So I told you I was going to show you how to do this in Excel first. Oh, Ratane, you know you're LeBron. Man, he is under contract until 2023. Look at her. Well, I hate to know he's getting paid out in LA. Awesome. Okay. So in Excel, pretty freaking easy to do a t-test. All you have to do is select the ranges. So, and then this is also part of the data analysis tool pack. So under data, we haven't done this in a while. Data analysis at the top right. And then you'll see t-test. Assuming equal variances. And then we've got our variable 1 range and our variable 2 range, the hypotheses, mean difference, labels, all that kind of stuff. So let's go look at what option we're going to look at. So it looks like I think I'm going to look at career free throws. And there we go. Yep. Assuming equal variance. Sorry, I should have hit clicked. Sort data by groups. Let's sort it by the group that we want to pick our data out for. So we need to select Excel because it's a little bit more, you know, we have to do a little bit more for it. We actually have to sort our data to get the groups isolated from each other. And then we go to data analysis, and then we go to two t-tests, rather. So this one is looking at free throw percent, and give me a second, let me make sure we're sorted. I can't remember I should have written out what my groups were. Maybe it's first round versus not first round.
And by sort, do you mean just in order from least to greatest, or is there a different technique?
Yeah, that's what I was going to do, Laura Beth, is just sort from A to Z, or take out the 10th. We can call that Z 10th. That way it'll sort better. There we go. So here we go. First round. You got plenty of players here in the first round. Then second, all the way to 10th. Okay. So now that we've got it, let's find our free throw percent. And career free throw percent is column G. Okay. So I want to make sure we can see both of them. Data analysis, 2 sample t-tests, assuming equal variance. Variable 1 is the career free throw percent for the first round draft picks, right? And it's one of those where you just kind of have to go with it. So all I'm doing is clicking and holding. And then coming to the end of the list, there it is. Boom. All right. So that's first round. Variable 2 range is everything from 2nd to 10th round. And no labels necessary. We can do a new, worksheet plot. So hit OK. And I may have actually been able to recreate what I wanted to do, right? Perfect. So I've already done it over here. I just wanted to walk through the steps with you. I'll just take it off. There we go. Oop, no, not the right one. Perfect. Okay. So what is variable 1? What is variable 1? What is variable 1 now?
Is it the career free throw percent?
Oh no, these are the grouping variables. What is group 1?
That's the first round draft pick.
First round, right? So let's relabel it. First round. Variable 2 then would be
All other rounds?
everyone else, right? So what do we know just on this first line? The average percent of free throws made. Which group has the higher average?
The first round pick.
First round picks. Are they statistically different? Is there a significant difference between round 1 and everyone else?
Yeah.
Yes, there is. I mean, this is 1.176 times 10 to the negative 5th. What that looks like, y'all, is 0.000011762. That's the alpha value. Okay. What about? Okay, you're good. All right. So yes is the answer. There is a statistically significant difference. So that's good to know, right? First round draft picks tend to do really well from the free throw line, or better at least. I mean, no one's great. 73% isn't really that great. To be paid how many millions of dollars a year to play basketball? Yeah, a couple of million at least. Hitting less than 3 out of 4. I'd hope that they'd be pretty close to perfect, but that's just me. All right. So that's the example in Excel. The way we report these results is because we're comparing averages. We are comparing averages. We can say, on average, NBA players drafted in the first round have a higher free throw percentage, the average scores in the 73, standard error 0.29, than those drafted after round 1, right? And we just kind of put their average and standard error there, okay? That's it, pretty easy. And then we say the difference is significant. We include the t-value and the degrees of freedom. So that's what 1738 is, degrees of freedom. The t-value being the t-stat, 4.36, and it's way less than 0.001 of a p-value, okay? Sound good? Kara?
Did you, I'm sure you addressed this. Why two-tail instead of one-tail?
Because it could go either direction. When we talk about tails,
Yeah.
when we talk about tails, we can basically, if we have a hypothesis, if we were doing research and saying, I hypothesize that the first round draft picks would have a higher percent free throw shooting, then I would use a one-tail test because I'm hypothesizing it's moving in one direction, okay? But because this is more exploratory, we're looking at it, it could go either way, right? They could be higher or lower. And when that's the case, we use the two-tail test. Make sense? Okay. I want y'all to do this now with average salary or maximum salaries. T-test again, just like we just did, right? You don't have to sort anything differently. Everything's sorted round 1, right? But now what I want you to do is I want you to go to data analysis, 2 sample, assuming equal variance, and I want you to highlight the max salary for all the first rounders. And then in variable 2, highlight the max salary for all the other rounds. And then let's analyze those data. Okay? Take a couple of minutes. Do it right now if you can.
And do you want us to use the max salary or the adjusted max salary?
Oh, good question. Yeah, let's go adjusted. Ignore this. I think I may have used max salary, but yeah, go adjusted. Because then it'll be more meaningful over time. Everybody good? Everybody done? Is anybody done? All right, Kara, tell us what you found out.
Okay, I didn't write down the format, but on average, now I've got to look at my decimal points here.
I've got it here.
Oh, there we go. On average, NBA players drafted in the first round have 69,420,098 salary. Oh, sorry.
Is it higher or lower? Okay.
Yes, they have a higher maximum salary. The median is like 69.5 million. The standard error. Oh, I don't actually have a standard error stat.
Not a median, by the way. I heard you say median.
You're right, I did.
Average.
It's average.
There's Laura Beth, is that what you were going to say?
Crikey.
Okay.
Thanks, guys.
You're good, you're good.
My t-test did not throw out a standard error.
Huh. Oh, let's find out why.
It
That's
did
weird.
equal variances, right?
Mm-hmm. I'll find out why. Keep going.
Okay.
Don't. Yeah.
Okay. Then those drafted after round one, let me cancel and go back to my numbers now. Their average salary was a little over 24 million. Yeah.
I think it's 2 million, 2.4 million.
Is it? You're right.
Just a decimal.
Laura Beth, would you like,
Yep.
how about you read my results for me?
I'm sorry. I've had like an entire pot of coffee before this class, so
It's gorgeous. I have at it. I prefer to have my commas where they're supposed to be. Oh my word.
Okay.
And then oh yeah, and that's a significant result. Less than 0.001.
Way less than 0.01.
Like,
Look at that.
super.
Negative 58. Yeah, crazy. No. So hey, can we assume independence of observations here? Is LeBron in the first round and drafted in the second round too? Is he all like he's only recorded in the data set as being a first round draft pick, right? That's what we mean by independence of observation. Like there's no overlap between these players. Okay. Okay, good. Now, let's do SPSS. Who wants to do SPSS? Does everybody have SPSS ready? Open, ready to go? Why don't we take a 10-minute break and let you get SPSS ready? Cool. All right. I've got 6:46. Come back at 7. I'm sorry. 8. Not 8. Come back at 8. Give you an extra 5. Okay. All right. Talk to you then. Here we go. Everybody back? Everybody good? Cool. All right. So
I'm back.
now, oh, what? Go. Who said what? Okay. Now we're going to take this a step further. We know that there's a difference in free throw percent shooting, right? For first round draft pick and all other rounds, right? But what about the first overall draft pick and the second overall draft pick? That's a group. That's an independent group also. So we can dig even further here and say, hey, does it matter who drafted first or second, right? What is your free throw, shooting like? So what we can do, first thing first, is before we even get to the t-test in SPSS, what we have to do is we need to go into data, the data menu, and select only the cases where the draft pick is equal to 1 or 2, where the draft pick value is 1 or 2, okay? So we're going to go to if a condition is satisfied. If a condition is satisfied, we're going to select the cases.
Yeah, we can't see.
There we go.
Okay.
Now you can see, right, Laura? All right. Thanks, Charles. Sorry. I was over here just clicking away.
So
All right.
you
All
said
you
you
minutes.
went to data. Yeah, can you go back? Thank you.
Yep. Data. Yeah, happy to, Rajana. Data. Select cases is the second from the bottom. So we're only going to select cases for this analysis if the draft pick, right? I believe that. If the draft pick value is 1, which is first overall, or 2, which is second overall. So drag draft pick over and say equal 1, or just type the word or, draft pick equals 2. That's all you have to do. And you have created these groups to compare. And when you hit continue, and then OK, minimize the output, go back to your variable, your data view, rather, look at your data view, and all the data that you should have in SPSS are first overall and second overall, and that's it. We've only selected the cases that were first overall draft picks and second overall draft picks. Make sense?
I have a. Okay, so in the beginning, you told us to recode it, and then we select the data, and then type in the if draft pick equals 1, then 2.
Or 2, or draft pick equals 2. Yeah.
Okay.
Yeah, so notice that draft pick, I've changed it to numeric here and nominal as a measure here. And then I did data, select cases, and I said if a condition is satisfied, so if draft pick equals 1 or draft pick equals 2. Continue, and OK. And that gives us only the first and second overall draft picks. So now what we're going to do is go to Analyze. And remember, I told you it's a lot easier in SPSS to do a t-test. You don't have to click and drag everything. You don't have to select those groups. So here we go to Analyze. And because we're comparing two means, comparing averages, we're going to go to Compare Means. independent samples t-test. And our test variable is the career free throw percentage. That's what we're testing. That's our outcome, right? The grouping variable is which draft pick they were, right? Draft pick 1 and draft pick 2. So that's how we're grouping our outcomes. So move it over, and you should have this option to define groups. You should have an option to define groups right below it. When you click it, group 1 is the first overall draft pick. Group 2 is the second overall draft pick. So you just enter 1 and 2 and hit continue, and then hit OK. That's all it takes. You don't, none of that clicking and dragging. Kind of nice, right? So now what do we see here? Anybody want to explain the output? Sorry. What's the average free throw percent for first overall draft picks? Is that better? What's the average free throw percentage? Okay.
Is
Go
it
ahead,
71? I'm sorry.
Yeah, 71%. 71%. What's the average free throw percent for second overall draft picks?
72, well, almost 73%.
Who's got the higher percentage of free throws made?
Second.
So, hey, you know, they're first in my book, right? Even though they weren't first overall. So, is that a statistically significant difference between those two groups? Is the next question. Kara, are you doing the slow, I don't know head nod, or is that like a, go ahead, Rachane.
I was gonna say yes.
Why do you say yes?
It's only by a couple points or a couple I'm not sure.
Okay. What do y'all think?
I vote no,
Why?
because the significance is 0.556. That's
Which is,
greater than 0.05,
and if it's greater than 0.05,
not statistically significant.
we fail to reject the null hypothesis, which is a very sassy way of saying we fail to find a statistically significant difference between these two groups.
Right.
And it's right here, y'all. The significance value is 0.56. Okay.
I was going to
Look at
ask
how-
about that.
Yeah. Well,
You
look
got
at
to
that.
look at that.
Yeah, I was going to ask of why the significance two-tailed column. Do those get calculated somehow to equal the significance column?
So this is Levine's test for equal variances. This is the significance for the two-tail that we want to look at. Look at the t-value. They're very similar, right? That's why the p-values are also very similar. We're assuming equal variances here, okay? Remember, that's the t-test that we wanted to run in Excel, was equal variances assumed. So 0.556 is still definitely not statistically significant difference. Yeah, sorry. Yes, the second overall draft pick on average typically does better at the free throw line, but there's a lot of variance there. There's probably a lot of overall first rounders that do really well at the free throw line, and there's probably good amount of variance. Again, all of that variation tends to muddy the water if they vary together or if they overlap. So yeah, this is a helpful way of saying no, there's not a difference statistically between these two groups. So the way that we would report this outcome is, while on average NBA players that are drafted first overall have a lower free throw percentage than those drafted second overall, this difference was not significant. And when it's not significant, when it's not statistically significant, I want you to report the actual p-value. P equals 0.56, okay? Not P is less than 0.6 or whatever it would be. Make sense? Cool. All right, let's move into paired samples t-test. We talked about paired samples earlier, right? This is when you measure something before or after, or the same group twice for whatever reason. We've got data on a survey that was done, not at my wedding. I should have done this because I love to collect and analyze data, but a survey was done after a series of weddings, and everyone was asked to rate their mood when they got there, right? As they're walking up to the church or whatever it may be. What's your mood like from a scale of 1 to whatever, 1 to 500? 1 being, I really don't want to be here, and I'm going to complain about it all night. And 500 meaning I am the DJ, even though they're not paying me to be the DJ, right? So we measured their moods before the wedding and their mood after the wedding. And really the only grouping variable we have, or not really grouping variable, but just comparison variable, is whether or not they're married. Whether or not they're married. Does anyone want to make a hypothesis? And I'm not saying we're not measuring happiness for married couples versus non-married couples. We're going to measure mood or whatever it is. We're going to measure the mood of the married couples before the wedding and after the wedding, and talk about any differences, okay? And we're going to talk about the mood for non-married couples before the wedding and after the wedding, and talk about the differences. So we're actually going to do 2 different analyses. Go ahead, Kara.
My guess is that for married couples, their mood is better after the wedding.
And thus non-married couples, or non-married people, rather?
I don't know, maybe worse. I don't think,
We'll
isn't
see.
everybody just happy at the end of the wedding?
No, after the wedding, not after the ceremony, after the full-on event, right? On the way home.
So after the alcohol.
Exactly. I was going to
After the garter, after the rice, after the flowers, whatever. Yeah, after. Yeah. So here we go. Paired samples, t-tests, in Excel. You can do it there. Again, we have to select our variables, right? We have to select our variables. So let's get that one up. There it is. All right, so married couple, right? I want to make sure I'm sorting my data by yes and no, because I don't want to run the analysis for all of them. I only want to run the analysis for yes, right? So go to, oops, I'll zoom in. There you go. So married, yes. Data analysis. T-test, paired to sample for means. So it's a paired t-test, right? Paired test. Okay. Variable 1 range is the mood before. So we're only going to select for the yeses that they are married, the mood before, and the variable 2 is the mood after for the yeses. Cool? Anybody want to interpret the results with me? What do we know?
So do we know that the mood for the married people went down after the wedding?
That's what it appears like, right? So how would we report these results?
That there, so we need to figure out what the significant difference, if there was a significant difference, right?
Well, first we might want to say what we did, right? And I like Manta's comment that stress after marriage. Stress after marriage, right? So what did we do? We analyzed data of married couples. We asked them to measure or to rate their mood both before and after a wedding. And we found that their mood before the wedding was higher or lower, higher than their mood after the wedding. Is there a statistically significant difference? What is our p-value, y'all? Am I sharing my screen? Do y'all see what I have on my screen?
You are. Is it
Okay, then
0.08?
what's the p-value? Is it 0.08, Kara?
I don't think it is.
Why?
Well, because we're doing a t-test.
We've used the two-tailed t-test before.
Yeah, I'm
Why
clearly.
did we use a two-tailed? Why did we use the two-tailed t-test before?
Because we were just wondering what happened. Did we ask, are they happier? We did, right? So
You made a hypothesis.
I did. I said it was going to go
So-
up. So then does that mean I use one tail?
So based on the one tail, what do we know?
It's moderately significant.
There's
That's
no
what I want to
significance.
say.
No. I've heard approaching significant. I've heard
Okay.
moderate. No. By the standards of 0.05, yes, there is a significant difference. However, it goes against your hypothesis,
Yeah.
right? The directionality is wrong. So everybody put your notes. Kara's wrong about happiness or the mood of people. No, I'm joking. But but that, I mean, that tells you something, right? I mean, it's not too different, right? They came in pretty freaking happy on a scale, or pretty, you know, in a good mood on a scale of 1 to 500. They left still in the 300s, right? But it was just barely different enough, barely different enough. What you'll learn the more and more you do t-tests is that you'll start to recognize the t-value. This little 1.74, that means you're really, really close to not being statistically significant. A t-value usually of about 1.53 means that you're starting to get into a significantly different, you know, mean, or significantly different calculations. But so we're really close here. Let's do it again, but for the single folks, okay? Any hypotheses this time?
Can you repeat the question again?
Does anyone want to make a hypothesis? No takers?
I'll guess happier this time.
You're going happier this time. Didn't you say happier last time?
I did.
Okay.
Can't help myself.
You're a very optimistic person, I guess.
I was about to say that.
I'm the eternal neutral party. Okay. So, Kara, or anyone else, please feel free to tell us what we learned when we looked at mood before and after a wedding for single people. What do we know?
It is higher.
What's that?
The mood is like higher, better after marriage.
Yeah, their mood increased, right? On average, moods were rated higher for single people after a wedding, or after the wedding ceremony. And by the way, what I was doing right here, this is the only dance I have. So that's why married people are less happy after a wedding, because their spouses are reminded of how bad they dance. Right? So I'm a terrible dancer. Okay, Manta, help us out. Is it statistically significant? Difference.
You said before, like for T, it's 1.67, so it's in the, what do you call it? Verge of being. I'm sorry.
No, you're good.
I'm not good at words. I would say that it is statistically significant, but not that much.
No, it is. It's right here. The p-value is right here for the one tail, because we had a hypothesis, so we can go with this one. It's well under 0.05.
Okay, I was looking at two tail. I'm sorry.
Oh, okay. Yeah. No. Yeah. Not the two tail. Not for this one. Because remember, if we make a hypothesis, we're only gonna look at one direction, one difference between the two groups. So, does this play out in your world? Are you happier after a wedding, or is your mood kind of sour?
I was going to say I'm usually happy.
Oh, all right. I've been to 1, 2, 3 weddings since I got married, and I've been married for a little over 3.5 years. And generally, I would say, I don't know, it's hard not to be happy, right, for other people. But nonetheless, that's how we do a t-test in a couple of different ways, right? A couple of different examples. Got all that done. We did this. Y'all talked through it. Good job. Is P less than 0.05. All right. Your discussion assignment this week. This week is, I think, maybe the only other week that you have a discussion and a lab assignment together. Okay. I've really tried to manage this for you, but I want you to do this because t-tests, again, very common, very much kind of the basis of a lot of what we do in terms of comparing groups. So do a literature review using t-tests as the statistical measure. Okay, you've done this before. I don't feel like I even need to rehash any of this. You've probably already memorized it. Your lab assignment. You've got two different things to look at. So part one, who here likes museums? Okay, cool. We've already looked at art museums, right? We've looked at the Metropolitan Museum of Art. Remember that? Well, this time, I want us to look at revenue differences between art museums and history museums. History museums are really starting to grow because we create history every single day. But also, a lot of people are just interested in learning about the history of places. So I want you to determine, is there a difference between revenue generated through art museums and history museums? So you're going to use real data, looking at museum data. So have fun with that. The other part two, is looking at quality of life. And quality of life is one of those concepts that I learned about back in my first master's degree. It was just one of those things, like I tried to understand it. It wasn't very easy to understand. But one of the things that I want you to do here is look. Let me see if I can find a file. That's what I was doing. So yeah, here's the museum file. Give it a second. It's fairly big, but not too big. It only has 25 columns and quite a few thousand rows. Yeah, 33,000 rows. But I gotta tell you, there are other museum data in here. I only want you to analyze art museums and history museums, right? Well, there's also science and technology museums. There's general museums. There's zoos, aquariums, and wildlife conservation. So all that to say, if you want to look at data for your project, I tell you that you shouldn't use data that we've already used in class, but I'm giving you a lot of data here that we're not going to use on the assignment. Okay? So if you need data, feel free to use the other data in this data file too. Who's got a favorite museum, by the way? Anybody have a favorite museum?
Guggenheim.
Okay, what is it? Oh, you say Guggenheim?
Yeah, I think it's in New
Yeah.
York.
Oh, I thought you said use mine. That's how I heard it. Yeah, I like the Guggenheim too. So I think it's GUGGN. That's in Las Vegas. So keep going. Probably a few of them. Oh, I just passed it. Dang it. I think this is it. Yeah, it's in Brooklyn. Perfect. So there it is. There's the Guggenheim Art Museum, right? Look at the scroll over. Yeah. Income is in column X. So it looks like they brought in 1, 2, 3, 4, 5, 6, $169 million in revenue. Cool, huh? A lot of money. Anyway, so it's pretty easy, pretty straightforward. Revenues are there. Income is here. There's a difference. There's a difference. What's the difference between income and revenue?
Expenses.
What's that?
Expenses.
No, that's a different category, but you're close. Revenue can be generated from multiple sources. Income is typically generated by selling a service. But if I die and I leave my estate to the Guggenheim, like the $10 that I have in my bank account, that's generated revenue for them, but it's not considered income. Make sense? So that's why I want you to use revenue, okay? It's a little bit more controlled. All right, I just saw your wedding conversation in the chat. It makes me laugh. Therefore, okay, so that's the museum data set. Again, pretty straightforward, pretty clean. The other data set is quality of life. Quality of life. And what are we looking at in terms of quality of life this time? Let's see. Ah, there it is. So the quality of life data, yeah, it's an SPSS. So I want you to do quality of life in SPSS. I just want to make sure I have that right. Here, the quality of life is looking at what their initial quality of life ratings were and what their after surgery quality of life ratings were. And we're looking at people who had cosmetic surgery. And we also have a little bit of depression data. There's a lot of reasons why after big surgeries, people take tests or complete surveys for things like depression and other stuff. This is a data set that I found that looked at when people have cosmetic surgery, if their quality of life changed, right? If their self-rated quality of life changed. So that's an SPSS for you. The other one's in Excel. Does anybody have any questions? This is the week before the presentation. Please reach out to me as soon as possible if you have a question about the presentation, okay? And because it's the week before the presentations, let's give y'all a little bit of your time back to go back and work on them, right? How's that sound?
That sounds good because if I'm understanding it right, we've got a lab, a discussion, and a presentation for next week.
Yeah, but you've had the presentations going for a couple of weeks now.
True.
But okay, so I'll stick around. Stick around if you have questions. I'll be happy to chat more. But feel free to sign off whenever you're ready, guys and gals.
Thank you.
Take care.
I had a question about the test, but I'm a little bit disheveled. Would it be okay if I emailed you about that? Your phone disconnected, Eric.
Oh, sorry, I clicked something. I said don't be disheveled. Oh, but yes, definitely contact me.
Okay. Yeah, it's just a Porto acting up, so should be okay. But thank you. I'll see you next.
You're welcome. All right. All right, and then there were 3, 2, Mamta.
Yeah, I had a question about the exam as well. I have emailed you, so could you check that afterwards?
Oh, is it about the the entering the values. I think I saw your email about that. Is that right?
Yeah, I hadn't rounded up, so I think there was some issue.
No, I'll definitely check into it. I haven't had a chance to get into that part of it yet, but ma'am, to expect a response from me at least tomorrow. Okay.
Okay, thank you.
Yeah, I'm sorry. I got swamped today and had to jump right in here with y'all. I didn't have a chance to look at it, but I'll let you know if I have any questions for you too. Okay.
Thank you.
Oh yeah, you're welcome. You're welcome. Let me know if y'all need any help with the presentation or anything else. Okay.